that are made entirely of DNA. Now imagine those tiny nanocubes could be used at any doctor's office to detect diseases within minutes, just like a blood sugar sensor for diabetes. It is a simple solution for a major problem like strained healthcare system, and it can also help remote communities with limited access to healthcare. And I'm working on improving the technologies of those simple tests by overcoming limitations like shelf life and accuracy to make a platform for many new tests. And each line you see on this picture is a DNA building block of a nanocube, which is placed on the gold surface with multiple sulfur attachments that act like a glue to make a more stable and reusable device. And spacing out and arranging the detection parts that you see on the top of the cube is the key for the device to be fast and sensitive. Because imagine how hard it is to find your friend in a crowded and chaotic room, right? But if the room is organized and everybody has their seats assigned, it's so much easier. And I can control the size of that cube simply by changing the length of the DNA building blocks to give me more space. And because I direct what goes into every corner of that cube, I can arrange the detection parts to match the shape of any specific biomarker I want. And without the nanocubes, it takes me 2 hours to make a measurement. But with the nanocubes, it takes just 10 minutes. So with the arrangement, spacing, and speed all in check, the nanocube can detect multiple things at once. And it's done by using red and green fluorescent molecules that will transfer the energy, but only if they're close enough. So you can think of wireless phone chargers, right? Your phone will only charge if it's close to the base. And so when I shine the blue light, and the two are close together, the red steals the energy from the green and glows red. And that means there is no disease. But if there is a disease biomarker, the red glow disappears. Because those two are now too far apart, so green keeps all of its energy and glows green. And that makes it incredibly easy to read. Red light, and it's all clear. Green light, and that means we have a disease, which might be a little bit contradictory with the light size we're used to. But with all that, with the control over the shape and the size of the nanocube, I can design the simple and fast diagnostic tools. And with it, I hope to bring a quicker medical tests that can be performed at any family doctor's office, making it available to anyone and anywhere. Thank you so much.